combustion, like burning, is a type of oxidation. Is combustion something you guys can control? Can you control the combustion? How much will get oxidized? To what extent can you oxidize it? Like, is that something you can control? Yes, no? What do you
I
guys
think we can control the amount of oxygen that is being used. So maybe yes.
Okay. Can you control the oxidation products though? See, oxidation is what? Like transfer of electrons and all, okay. But when we're looking at a reaction with oxygen, oxidation is basically addition of oxygen, right? Now this addition of oxygen in combustion, what is happening is like oxygen is being added to carbon and hydrogen separately, like carbon being oxidized to carbon dioxide and hydrogen being oxidized to water. But you also have carbon compounds. Like if we start off with methane, you also have like a derivative of methane by adding of an oxygen, which is methanol. Like if I convert methane to methanol, this is also oxidation. So can I control what sort of product I would get at the end of oxidation in a combustion reaction? Can I stop it, I don't know, midway or something? Can I control the reaction so that I get methanol instead of carbon dioxide?
I don't think so.
It'll be difficult. I mean, imagine you guys must have lit candles and all often, like a lot of times, right? You guys have yeah, it's gonna be difficult. So if you want to get other oxidation products of alcohols, you can go through like controlled oxidation, which is not directly making it react with oxygen. You are going to make it react with other compounds that contain oxygen that can give out oxygen atoms. Okay. So controlled oxidation is basically something that you do in laboratory and all of that. So one way of controlled oxidation is one, like you heat it with a regulated supply of oxygen. So you regulate it, you know, how you regulate gas on your burner. That way you control the quantity of oxygen that you're supplying. Second is you do these reactions at extremely high pressure. And three is you use catalyst to, you know, that's another measure of controlling. Okay, so for example, there are quite a few catalysts that you can use. Let's take methane only. So if I make methane react with oxygen in the presence of copper at 523 Kelvin at 100 atmospheres. So 1 atmosphere going haywire, but at extremely high temperatures and pressure, if I conduct the reaction in the presence of copper, then I get methanol. And the next degree of oxidation, this is like the lowest level. You can think of it as lowest level of oxidation. Okay. The first oxidation product is alcohol. Make it go slightly more oxidized. Use molybdenum oxide with heat. You end up getting methanol, formaldehyde. Okay. And if I use an extremely strong oxidizing agent, something like manganese acetate, and heat it with a little bit of that, I end up getting methanoic acid. So you can think of these
What's
as
MO2O3?
molybdenum oxide. MO is molybdenum.
Okay.
Molybdenum. So इसका oxide है. So this is an element, one of the elements. Like I'll see where it comes from. It's a D block element for sure.
I had a small doubt from the start of the chapter. So, like these catalysts that are being used, yes, I mean, helps in the reaction, right? It doesn't really add up to the product, correct?
Yeah, it helps in the reaction. Like in this case, these are the ones that are like they provide nascent oxygen. So another really strong oxidizing agent, usually if you start off with alcohols, there are two major laboratory oxidizing agents. One is KMNO4. You must have come across permanganate a lot, like when you're doing redox reactions, MnO4 minus. And another one is potassium dichromate, A2Cr2O7. So these two are extremely strong oxidizing agents. And you can take this in alkaline condition or acidified condition. You can change the concentrations and all that. So based on how strong of this compound you take and based on alkaline or acidic conditions, you can oxidize alcohols to either aldehydes or uh, carboxylic acids. So that way, these are other oxidizing agents that you can use. So basically these, like there's going to be redox happening there, and during the process, they release like nascent oxygen. And how much oxygen they release will control how oxidized this reactant can get. Yeah, Kaveri, what's up?
On the second and third reactions, we are oxidizing the alcohol or CH4.
No, CH4 only. Like if I write it this way, like this is the reactant that's common to all the reactions.
So depending on the catalyst and the temperature and the pressure, we'll get different reactants, products.
Yeah. So again, this is a controlled oxidation, right? You're controlling how much oxidized can the reactant get. You want it slightly oxidized, you get alcohol. Go a level higher, you get aldehyde. Go a level higher, you get acids directly.
Ma'am, we say that catalysts, they speed up the reaction, but in all of the reactions that we've learned till now, like without the catalyst, the reaction would not have been possible, right?
Yeah,
So
they're
what
like
catalysts do?
Catalyst, it's not like they exist solely to speed up the reaction. They enable the reaction to take place. Now, if I didn't have the catalyst, if I simply heated methane with oxygen, I am going to get carbon dioxide plus water. That's my uncontrolled oxidation. That's the combustion reaction. But the presence of these particular catalysts is making the reaction take a different route so that I get these products and not directly the combustion K products. So rather than catalyst, okay, so this is catalytic oxidation. You can call them reagents in these cases instead of catalysts. Yeah, that would probably be a better word to use. Basically, depending on what reagent you take, you're controlling the reaction. You're controlling what product you can get at the end of the reaction. That's why I've highlighted the word like regulated over here, because yeah, it's controlled oxidation. So you're regulating to what extent the oxidation can take place. Yeah, Rishabh, what's up?
No, ma'am, by mistake. I mean, by mistake, it was unmuted.
You can take another note. I'd mentioned like these two are really strong oxidizing agents, right? So when it comes to tertiary carbons, if you want to oxidize tertiary carbons, none of this is going to work. It is really difficult to oxidize tertiary carbons. So for the sake of tertiary carbons, you can oxidize them only in the presence of permanganate. Like I'll give you an example once you guys are done noting this down.
Ma'am, the ones you've written on the side, those are strong oxidizing agents. So we don't use them in these reactions.
If you use them in these reactions, it won't be controlled oxidation. This will directly get oxidized to acid.
Ma'am, could you repeat like your point of tertiary carbons being hard to oxidize?
I will. So once you're done noting this, I can go to a fresh page so that I can write it for you. Yeah. So Kaveri and Rishabh are remaining, right? Kaveri is also there.
Ma'am, what was the last thing you did in the previous class?
Combustion reaction.
Okay.
You can note down the name. Like you can see that first step may you get alcohol. In this case, because I used methane, I got methanol. And here I get aldehyde. Here I get acid. And yeah, when tertiary alkanes, like for example, like they're difficult to oxidize them. So you have to use like really strong oxidizing agents like potassium permanganate. So strong oxidizing agents required. So like for example, tertiary alkane, if I have CH3 taken thrice CH, so this is a tertiary alkane. So when I write thrice like this, it means that this carbon is connected to 3 CH3s. So if you want, you can write the expanded form in your notes, but if you're able to understand it, you can write it in short form. So this can be oxidized only in the presence of KMnO4. So this will give you a tertiary alcohol. So in general, you can write down somewhere on the side in a different thing or something. So this is like the order of oxidation. So anytime you come across oxidation of any of these reactants, this is the order in which it's going to follow. So if you start off with alkane, first it's going to get oxidized to alcohol. So then alcohol gets oxidized to aldehyde or ketone. So whether you get aldehyde or ketone depends on what kind of alcohol it is. Ritu is asking, what about oxidizing the 4-degree carbon? So that will not get oxidized. if you use an extremely strong oxidizing agent like acidified hot concentrated KMnO4, it is going to break the bond between carbon and carbon, and you get like the respective alcohol or aldehyde or ketone, depending on how strong you use it. Okay. And the aldehyde or ketone, on further oxidation, you're going to get the carboxylic acid. So aldehyde, because they're on the corner, becomes carboxylic acid easily. Ketone, like the chain breaks and you get two different carboxylic acids. Like you really need a really strong oxidizing agent in order to oxidize ketones.
Ma'am,
Hmm?
I didn't understand this order of oxidation. Could you repeat this again?
Yeah. So order of oxidation, matlab, it depending on the strength of the oxidizing agent. So if you use a really weak oxidizing agent, alkane gets oxidized to alcohol. Then if you use a slightly stronger oxidizing agent, then you get aldehyde or ketone. And then slightly stronger oxidizing agent, then you get carboxylic acids. That's all it is. So if
The reactant side may we will have alkane only in all these three cases.
you can have anything. Like right now, since we're studying alkanes, you have reactions with alkanes. But when
Correct. You have alkane, then alcohol, and then alcohol, and then aldehyde. So aldehyde from alcohol or aldehyde from alkane?
either, like if you use a really strong oxidizing agent, whatever alcohol is produced will automatically get converted to aldehydes. And if you start off with an alcohol, you're going to get aldehyde on oxidizing it.
So the alcohol will further oxidize.
Yeah. So if I take, even if I take C2H6, and if I use something like acidified KMnO4, now because this is extremely strong, it's going to bypass all these steps. Even if it is formed, like you won't be able to control it. End of the reaction, you're going to find acetic acid only. So depending on the strength of the oxidizing agent, it can be oxidized to either alcohol, then or aldehyde or carboxylic acid.
Ma'am, so I had a doubt. Uh, so it is possible. So if only there is alcohol, it will be turned into. I mean, sorry. If there is like what do I say? Like a strong acid only, then it will be turned into an aldehyde, or else it will be directly turned into. I mean, so could you like explain this again? I did not really understand.
It's the same thing. You've noted this down, right? So you start off with an alkane. Weak oxidizing agent like oxygen, the presence of copper at this temperature and pressure, you get alcohol. Slightly stronger, heated with molybdenum oxide, you get aldehyde. Really extremely strong, like manganese acetate or KMnO4 or dichromate, you directly get acid itself. So that's what I meant by order of oxidation. So the stronger the oxidizing agent, the later the product you're going to get.
And why does the chain break after ketone?
That is because, like, if it's a secondary alcohol, secondary matlab, this is the structure, right? So when this is oxidized, basically this H gets removed and this becomes a double bond. So you end up getting a ketone. And ketone को अगर oxidize करना है, so basically this has to turn into COH. Like if it's an aldehyde, it's at the end, there is hydrogen only here. So this hydrogen turns into an OH, so you get a carboxylic acid. Now you don't have that opportunity in ketone, right? So you need to take a strong enough oxidizing agent so that this bond breaks, and then you end up getting a C double bond OH, and this other side of things also you get like C double bond OH, an aldehyde or and an acid, or like two acids depending on the concentration.
Can't the ketone become an aldehyde? Because like since we're adding an OH and it's becoming the same thing. Sorry, not aldehyde, carboxylic acid, because we're adding the same thing, right? It's
How?
becoming an
Like if I have C double bond over here, and then I have two carbons on both the sides, like where will I add an OH? In order to add a OH, like some bond needs to break over here, no? For the oxygen to get in.
okay. So it's never like adding just oxygen, it's always OH, it's always adding alcohol.
Like alkane, you have all hydrogens there. So the oxygen gets in between. So you end up getting an alcohol here.
Why doesn't the oxygen substitute the hydrogen? Why does it have to get like added to the hydrogen to become alcohol? It could also substitute instead of.
That's what is happening. The hydrogens get removed because there's only oxygen. That's why you're getting an aldehyde here.
Okay. Oh yeah. Right. Got it. So in the strongest case, the hydrogen gets removed. Like, but when we use in the most controlled state, it's simply the O gets added, so it becomes OH.
Strongest case, hydrogen is removed, more oxygen is added, like C double bond over here, and then this also becomes an OH. That's why you end up getting a carboxylic acid.
Got it.
So when it comes to controlled oxidation, this is the pattern, like this is like a given, you can easily remember it. We're going to revisit that when we do alcohol, when we do aldehyde, when we do acid also, like alcohol oxidation of alcohols follows this order. The only thing you guys will need to remember is the oxidizing agents. On like using copper, you need to remember that you get alcohol. So you just remember these oxidizing agents. That's what is important.
Ma'am, I had a doubt. So, yeah, what exactly will be the questions asked about this?
Again, right from the beginning, I've been saying the exact same thing. They all follow the same, like you have a substrate, you have a reagent, and you have a product. You'll be given any two out of this, and then you'll be asked for the third thing. So one way a question will be asked is an alkane, let's say containing 4 carbon atoms, is made to react with molybdenum oxide. Then predict the product. Or you may be asked, okay, like if I wanted to produce ethanoic acid from ethane, what is the reagent that I can use? Or I'll be asked, like I got let's say ethanol by heating some alkane in copper with oxygen at so and so temperature and pressure to identify the original compound. So always make notes, make a separate table, make a chart, whatever you're comfortable with, but learn it in this way. Like for a particular substrate, if I use this reagent, I get this product. Because that's how you'll be asked the questions. Like Even in questions, you should be able to remember correctly कि अच्छा अगर ये reagent है तो ये product मिलेगा, अगर ये product मिला तो basically these are the two things used that way.
Ma'am,
Yeah.
you showed, can you go to the next slide? So you showed how the alkane is becoming the aldehyde. Now, in case of alcohol, when we already have an OH, how will the O substitute?
I didn't get you. What?
Like you showed how when alkane becomes aldehyde or ketone, so the H is the H is instead of the H, the O replaces it basically. Now, when we go, you said either from or alcohol or alkane we can go to aldehyde. So when we go from alcohol to aldehyde, when we already have an OH, how would the reaction take place?
So we'll get into the mechanism of it. So we'll do that when we deal with alcohols. Just know that oxidation of alcohols will give you aldehydes.
Okay.
So the only special case is you need to remember about tertiary alkenes, because once you get tertiary alcohol, because this is connected to 3 other carbon atoms, it's difficult to convert this into a double bond. So oxidizing this further is going to be very, very difficult. So another type of questions may be about this, that let's say you have 2 alkanes. Both have C4H10 as a molecular formula, but in one case you're able to get carboxylic acid, in the other case you only got an alcohol. So if you had to identify what was your original alkane, what would you say? Like किससे acid आएगा, किससे alcohol आएगा, having the formula C4H10.
I didn't get the question. Could you repeat?
I'll do it properly in a different. I'll ask it in a proper question form. Everybody's done noting this down, right? So I'll go to the next page.
Right.
Writing it again.
Ma'am, 1 minute.
Yes, ma'am, done.
Ma'am, do we need to also draw these structures?
You can, if it will help with your, understanding, if it makes sense to you, definitely. See, the notes are for you guys. However, it make like it. I don't expect you guys to copy this exactly as it is, other than notations and things like that. However, you think it will help you study, do that. If it helps you to write it in the form of sentences, do that. If it helps you to do it in the form of like tables and bullet points and short forms, do that. But you need to understand, okay, what is the content? That is the aim of the taking notes.
Ma'am,
Yeah.
the fourth structure that you've drawn, that's for carboxylic acid, right?
Yeah. That's why.
And could you draw the structure for aldehyde?
Aldehyde, here it is. CHO, HCHO.
Okay, then keep the other one, like whichever is.
Ketone, I'll need to take a secondary thing, for example. You also figure it out. So when you submit the notes, if there's an issue, I'll point it out. I'll let you know. The logic would be the same. Like wherever there is OH, that gets converted to double bonding. That's why when I take a primary alcohol, I get aldehyde. If I take a secondary alcohol, I get a ketone. Cool. Can I go to the next page? All right. If you're still writing, speak up. Otherwise, we go. So I'm saying an alkene or So two alkanes, both with molecular formula C4H10. Okay, this is an important clue. So you have two alkanes, both have C4H10 as a formula. Let's say they are A and B. Okay, so A on oxidation with KMnO4 gives an acid. B on oxidation with KMnO4, same process, gives an alcohol. So what are the possibilities? What could A and B do? So I'm just looking at the fact, whether you guys got the logic of it or not. So send your answers. If it is likely, if it is possible, it's fine. Otherwise, I'll correct you. Both of them are butane only because they're all C4H10 only. Unless you're giving the exact IUPAC name for both.
Yeah, I'm trying to give the IUPAC, that's why.
Okay, then B is not butane.
I made a typo. I'm just resubmitting.
Okay. Yeah, I saw there's some typo there.
So we don't have to give IUPAC necessarily, or like we have to give IUPAC only? If it's no, then is
Just
it?
identify them.
No, then to C4H10 is the formula for butane then. Otherwise.
Yeah. So both A and B are some forms of butane, C4H10 only. So if you're talking about IUPAC name, then B is not butane. Rishad, you didn't understand the question here. I said, when I oxidize B, I get an alcohol. So B itself is not an alcohol. Also, whatever you sent, that's not making sense because if you write CH3 taken thrice CO, like wahi pe carbon is having more than 4 bonds, and which is not correct. Check again. Ritu, yes, A is correct and B is also correct. So far, Ritu has answered correctly. Good. So instead of sentence, if I were to put it as an equation, so I have A on oxidation, I got an acid. And because it is C4H10, I can write something like I got either this or it could be this. Either or. Basically, I have to get acid, and because I started off with C4, there needs to be 4 carbon atoms. B, I got an alcohol. Okay. Which means that using the same oxidizing agent. I used a pretty strong oxidizing agent. In one case, I got acid. The other case, I got only an alcohol. So what could it be? आदित मीथेन कैसे हो सकता है? C4 है ना दोनों का फॉर्मूला?
I might not have understood the question, but if I'm correct, so there are two alkanes with CH4H10 formula, and they are getting oxidized.
Not CH4, whatever.
No, I told C4. Okay, maybe by mistake. So, so they are the ones that are getting oxidized.
Correct. Both A and B C4H10. One of them, this is coming. The other one, this is coming. Yeah. Based on the question, like this is how I would go about it. If acid aa raha hai C4H10 se matlab it will be a 4 carbon acid. Like ये हो सकता है या फिर ये हो सकता है. Like there's no other thing we can figure out. B is alcohol. तो अगर सेम स्ट्रक्चर है तो सेम प्रोडक्ट आना चाहिए ना. तो अगर अलग प्रोडक्ट आ रहा है मतलब इसका स्ट्रक्चर अलग होना चाहिए. So think of it in those lines. Which compound will give me an alcohol and which compound will give me an acid? Use whatever notes I've given here. Like use this. It is completely based on this. Ritu has figured it out. Like good job. Well done. Smera, Kaveri, how was it going with you guys?
1 second.
Okay.
Ma'am, I'm sending an answer. You can just check it. I need a opinion on this. Is it correct or not? 1 second.
Okay. Rishit, no. It like facts are given. Alkanes are है दोनों. C4H10 है formula उनका. तो वहाँ पे oxygen is not given. So how can you add it? You can reverse engineer it, but final answer that you give me should be C4H10 का ही कुछ. Adit, yes, Adit, you identified
correct.
things correctly. Yes.
Okay.
Smera got B correctly. A के लिए I've already given like possibilities of two structures right here. So what could it be? Kaveri, you gave me the formula for the alcohol, but like you've learned about isomerism and all that. Also the fact that strong oxidizing agent के साथ normally you're supposed to get like aldehyde, ketone or acid. लेकिन alcohol तक ही we got stuck. So क्या हो सकता है? Also, you're supposed to give me two possibilities, Kaveri. Like we have A and B, and both of them are alkanes with this formula. Sanat, you're quite close. The product from B is that, but you're supposed to identify the alkane from where you get that product. Read the question twice, thrice. Two alkanes, molecular formula C4H10. A, one of these alkanes on oxidation gives an acid. The other alkane on oxidation gives alcohol. So you need to identify what these two alkanes are. Your final answer should be an alkane.
Ma'am, I'm sorry, I got disconnected if you said something.
I'm still on this question.
Okay.
Smera and Adit, you guys give me the answer for B. What about A?
Wait, I told the answer before. Wait, I sent it again.
So we need to, before it, like let's say for B, before it became an alcohol, what was it? Like before it became oxidized.
Correct. Yeah.
And it was in the formula C4H10.
Correct. Adit, yeah. So Ritu and Adit have given me both correctly. Smera, one tiny mistake. So if I count your formula, it's C4H9. So just correct that a little bit. C4H10 hona chahiye. Kaveri, the thing that you sent, was it before or after you clarified it with me?
Before.
Okay, then I'll ignore. Adit, yes. So Adit and Ritu have gotten it. Smera has almost gotten it, but not quite. You're 99% there. Now whatever you sent, that is correct. So Ritu, Smera and Adit have gotten it. So, Kaveri, Sanat, Rishit and Arnav. Okay. You guys have taken down the notes, right? Like flip through your notes, tell me what gives an alcohol when oxidized with something like KMnO4. This is a direct question. You've written this earlier. So on
Can
oxidation.
you repeat the question?
Yeah, what gives an alcohol on oxidation with KMnO4?
The example that you gave us was CH3 thrice CH. That was the alkene. Sorry, that was the alkane that
What was
becomes
the
CH.
point generally? Like what have you written there?
Third degree alkenes.
Third degree, tertiary.
I mean tertiary. Yeah.
Correct. Right. So yahan pe, if B is giving me alcohol, what should B be?
Oh, so should it be connected with 3 carbons?
There you go.
So C4H10 thrice.
No, B is a tertiary alkane with the formula C4H10. So can you create an alkane with 4 carbon atoms, which is a tertiary alkane, which has a tertiary carbon atom there?
Wouldn't it after all give the same example which you gave?
Yeah.
I didn't get it.
You know what tertiary alkanes are, right?
Yeah, connected to 3 carbons.
Now that is one hint. Second hint is B has a formula C4H10. So B is basically a compound with 4 carbon atoms such that it has a tertiary carbon atom. Now do you get it?
So one of the 4 carbons is connected to 3 more carbons.
Yes. Rishit, both have C4H10 only. You're supposed to give me what, like, either give me the structure or give me like the IUPAC name for both. A is also C4H10, B is also C4H10. But if they are two different compounds, clearly they are isomers of each other. So you need to tell me which isomer both of them are. They are structural isomers of each other. Yeah. Sanat and Arnav, what about you guys? Yes, got it. There you go. Sanat got it. Nice. Yes, Rishit. Rishit also gave me the structure of B. Yeah. So B, so let's put it together. Like it is C4 and there should be a tertiary. So let's draw the tertiary. So char carbon atoms accounted for. So the remaining should be hydrogens only. So if you just do a quick verification, C4 hai and H, 3 3s are 9 plus 1, 10. So this is C4H10. So this is B. And A, because I got an acid, it's got to be either primary or secondary. Secondary though, well, it's not possible here. So it has to be the primary thing. So this is A and this is B.
Why secondary is not possible?
Can you create a secondary carbon atom with this? If I take the CH3, attach it over here, I'm going to get a tertiary thing only.
A is basically just the normal chain, right?
Yes. So I would have accepted if you...
I actually for the A I gave that thinking you would consider it as the normal only.
No, that's why...
Okay, I'll next time to give it like this.
So if at all you'd given me both A and B, and if you'd given me both A and B ka IUPAC names, no, then I would have understood it. But if you gave me only A being butane, then I don't know what you have in mind for B, right? So until then, I wouldn't have considered it. So this is what I was looking for. अगर दो अलग-अलग products आ रहे हैं, मतलब both should have different structures. So again, that's why I kept saying C4H10 मतलब butane ही है, but which butane is A and which butane is B? So if you told me N-butane, isobutane, or even if you told me like normal, like if you gave me A is butane and immediately gave me the name of B also, then I would have considered it. But I wanted like some sort of a difference to tell me that, okay, you know there's a difference between A and B. That is why I wasn't. Until you gave the structure of B, I wouldn't be considering it. Okay.
So for primary and secondary cannot make alcohols with KMNO4.
No. KMNO4 is so strong that it's going to bypass all of them and straight away give you carboxylic acid. Okay. So this is like one sort of, the direct question would be the substrate reagent product wala thing, where you'll be given the substrate and the reagent, identify the product. This is more of a slightly higher level question. This is another type of question that you will be asked.
Ma'am,
Yeah.
I'm still a bit confused about the relation between the order of oxidation, primary, secondary, tertiary carbons. Like, how is that related?
So always alkanes get oxidized to alcohols. So that is the first step. The difference between primary, secondary, tertiary comes into picture for further oxidation. So if I use a stronger oxidizing agent, alcohols get further oxidized to aldehydes and then acids. Specifically in the case of tertiary alkanes, right? See, that kya ho raha hai? I need to lose one hydrogen so that this can get converted into a double bond, right? But यहाँ पे tertiary alcohols में यहाँ पे कोई hydrogen नहीं है. I have like alkyl groups only directly attached on all three sides for all three bonds. So if there is no hydrogen to lose here, like for this carbon, it cannot form a bond with double bond. So only for tertiary alkanes, it's not able to go further. So even on using a really strong oxidizing agent, I'm getting stuck at alcohols only. But with secondary and primary alcohols, I do have more hydrogens to spare. So they get eliminated and then I end up getting aldehydes and acids here, especially for primary alcohols.
Okay, so when we don't have more hydrogens to spare, then what?
Then if I don't have hydrogens, I can't lose those hydrogens, right? So yahan pe, how can this carbon form a double bond? It can't form a double bond because all the valencies are filled. Extra bond nahi, like it can't like have 5 bonds, no?
So how do we see that that's tertiary?
How do you identify tertiary carbons, Kaveri?
The central carbon has to be attached to 3 carbons.
There you go, from the formula.
Oh, right. Okay. Okay. Yeah.
So the hint here is, here nowhere it tells you it's tertiary. But the fact that you're ending up with alcohol only with KMNO4 should tell you that acha, that means B is tertiary. Acid nahi aaya, alcohol hi aaya, matlab tertiary. That way. Okay. Cool. So that's for
Other oxidizing agent for tertiary, we won't end up with alcohol.
You won't end up with any sort of oxidation only.
Okay.
So tertiary को oxidize करने के लिए it takes a little bit of you need a really strong oxidizing agent for that. Okay. All right. Next.
Sorry, but in tertiary we do have. Oh, right, that's carbon. So we don't have hydrogens to spare. That's why it's harder to make another bond. Okay.
Yeah, like the reaction, like it doesn't have a way to go through. Like mechanism may, if it needs to use a hydrogen, there's no hydrogen. Like what's it gonna do? Okay. Next reaction property, we have isomerization. So naam se you can like kind of figure out what this reaction is going to be about. What do you think?
Isomers.
Yeah. So you take any N alkane, basically any straight chain alkane. Then the reagent that you use for isomerization is anhydrous AlCl3 in the presence of HCl, like HCl in the presence of anhydrous AlCl3, basically you could say. So this is the reagent that you take, and then you get the isomers of an alkane. So basically, if you want to create branched chain alkanes, you use this reagent and it's gonna rearrange. These are straight chain alkanes. Okay, so for example, if I take N-butane, so the reagent This is what you need to remember. For isomerization, take HCl and anhydrous AlCl3. You end up getting isobutane. Rishit, no, the triangle means heat. You've been doing reactions since like 10th standard, Rishit. Delta always means heat. If it is STP, it will be mentioned as STP over here. STP is like specific temperature pressure conditions. Either STP will be mentioned or that particular temperature pressure will be mentioned. Triangle means heat. Yeah, Kaveri.
I have one last doubt regarding the previous question.
Okay.
So if we weren't, if we hadn't been told that it was the molecular formula was C4H10, we still would have been able to figure out, right? Because if we know that it has to be a tertiary carbon to get an alcohol, we can directly just say C, and so obviously at the hydrogens that we attach will be C4H anyway, right?
What if it was this? Could be 5 carbon atom or it could be 6 carbon atom. Like yahan se you just know there's a tertiary carbon, but you don't know which particular
part.
it is. Yeah.
Yeah. Okay. Got it.
So without C4H10, like they both could be completely unrelated because you're not given the formula of the acid and the alcohol that's formed. So it would have been information insufficient. But if
We
there
can
were,
basically
but
we
if there
can
were,
get alcohol even normally, but then only because we have KMNO4, that is why it should be tertiary, right?
yeah, you're getting alcohol with KMNO4. So if I didn't specify KMNO4, again, it wouldn't have any meaning because I don't know what I used for A and B. Like they could have been the same thing, but I could have used like copper in one case and KMNO4 in the other case. Like there's just no way of figuring out, okay, like all the information needs to be there. That's how you can put this together. Even if one of them is absent, then the possibilities would be a lot. So all of the information is required. You need to make sense of this. So Kaveri, another point that you mentioned, if I did not give C4H10 and then I gave you 4 options, then you will need to choose the option where one of them was tertiary and one of them was primary or secondary. Like I could have given options such that यहाँ पे एक primary, यहाँ पे एक primary, then यहाँ पे secondary, यहाँ पे secondary, यहाँ पे primary, secondary, tertiary. So then based on this, ये नहीं हो सकता है because फिर दोनों में acid आना चाहिए, लेकिन acid alcohol आया मतलब this is wrong. Similarly, this also will be wrong, this also will be wrong, so this will be the correct option. If at all C4H10 was not given. But essentially, we are all revolving around the same concept that अगर KMNO4 के साथ alcohol आया मतलब ये tertiary होना चाहिए and acid आया मतलब primary या secondary होगा. The rest of it depends on what other information is given in the question.
And for acid, though, we don't need to know if it's tertiary or not. So that we could have, that also we couldn't have done without knowing it was C4H10.
It could have been C2H6 because that also gives you an acid. Or it could have been C3, C3H8. Or it could have been N-pentane, like that way. Anyway, coming back, isomerization के लिए, this is the reagent, this is the equation. I would consider this another, okay, it's not exactly isomerization. So another next equation is aromatization.
Ma'am, I actually had a doubt like about the previous one.
Oxidation.
Yeah, how do you know if it's like isobutane or like isopentane, neopentane? Like how can you tell which one it is? Like the isomers.
What do you mean?
Like supposing you had pentane and you put it like through like anhydrous AlCl3 in presence of HCl. Like
Oh,
how would you be able to tell if you get like isopentane or neopentane?
you can't tell. You might get like a mixture of products. Basically, you end up getting isomers of the alkane that you take. Basically, treating it with this particular reagent will create branch chain.
So like if you ever had to like write it, you just write all the possible isomers.
Yeah.
Okay.
And then we have aromatization. So which is the simplest aromatic compound that you guys know of?
Benzene.
Benzene.
And
Benzene.
benzene has how many carbon at what's the formula for benzene?
6
C6H6.
Right. So if we want to convert an alkane into an aromatic compound, can I do that with propane, 3 carbon atoms के साथ? Will it be possible with
You could
propane?
treat it with like dry ether and get like 6 and then do it.
So again, you are anyway converting it into 6 carbon atoms and then doing it, right? But this specific reaction, aromatization ke liye, you need minimum 6 carbon atoms required. Like, let me put in proper sentence. So this reaction will be undergone by alkanes with greater than or equal to 6 carbon atoms. So less than 6 carbon atoms, you will not get an aromatic compound simply because an aromatic compound does not exist. Yeah. So the reaction
For the isomerization, it is anhydrous aluminum chloride, right?
Yeah.
It is anhydrous, right? All right.
Get familiar with anhydrous AlCl3 because this is also, we'll keep coming across this in a lot of reactions simply because the anhydrous AlCl3 acts as a Lewis acid. So it is electron deficient, so ends up being a Lewis acid. Okay, anyway, coming to aromatization, again, in this case, the catalysts are kind of important, something you need to remember. So suppose you have benzene, hexane.
Ma'am,
Hmm?
for aromatic compounds other than benzene, we don't need to have less than or equal to 6 carbon atoms, right?
You need to have minimum 6. If you have 7, then you end up getting toluene. If you have 8, then you end up getting, dimethyl benzene. But you need to have at least 6 because less than 6, you don't have any aromatic compound that, this reaction can take place at all.
Basically, we have to have benzene in the product.
Yeah. It's aromatic, right? So
No, like, but are there any aromatic compounds that have more than 6? Like you said, toluene, but isn't that aromatic also?
yeah. So
So
toluene,
then why do you say it has to be less than 6? Oh, sorry, more than
toluene has how many carbon atoms total?
7?
right? So we need alkane with 7 is more than 6. So we need at least 6
So
carbons.
like the minimum is benzene and then uske upar whatever.
Yeah. I can't do it with 5. Like I can't do it with butane, pentane, propane and all. I need to have minimum 6.
I remember, I don't know when, but the teacher giving an example of something like with 4 carbons, but it also had like some 5 carbons something, but it also had alternate double bonds. So wouldn't that also be an aromatic compound?
You do have aromatic compounds with 5 atoms in the ring, but that's not a hydrocarbon. So that would be heterocyclic. It would be furan, I think.
Okay, got it.
I have an oxygen here. That's the difference. Yeah.
Why do like 2 carbons have CH3?
Because this is a reaction of alkanes. I took hexane. I just drew
Oh,
it.
this is hexane.
Yeah.
I thought you took a benzene ring.
No. We are talking about chemical properties of alkanes. So यहाँ पे हर एक reaction में your reactant is going to be some alkane.
Oh, okay. I got confused because it was in that hexagonal shape.
Yeah.
But this is cyclohexane, right?
No. Do you see a cyclic thing? There's only bonds यहाँ तक.
Acha, okay.
I just wrote it in like a twisty way because you can see यहाँ से यहाँ conversion कैसे हो रहा है. Like we're just losing the hydrogens out and then introducing double bonds here. This is quite important, so I'll put it in a different color. So the reagents that you can use for this, you have chromium oxide, Cr2O3, or you can use vanadium pentoxide, V2O5, or you can use molybdenum oxide, MO2O3. Now the temperature in this case, you need to heat it at 773 Kelvin with a pressure of 10 to 20 atmospheres. So these reactions, isomerization, aromatization, you don't really have like logic or mechanism or anything like the previous ones, like what we saw in substitution and all. You just need to remember कि isomerization के लिए ये reagent चाहिए, aromatization के लिए ये reagent चाहिए. Yeah. These are like the important things that you need to know.
So the one in the reactant side, that is just an chain, right? That is not a ring.
No. यहाँ पे CH3 है, यहाँ पे CH3 है, यहाँ पे कोई bond नहीं है. So this is just hexane.
Okay.
Converting into benzene. I just wrote it differently. Like if you want, you can write it as a straight chain. So I wrote it in this way because then, you can see that we are not folding a straight chain into this thing. Like when we talk about straight chain carbons, because the bonds are all tetrahedral, they are not going to be straight chain like a ruler or something. You're still gonna have this sort of a structure present. You know what? I'm gonna order like that one of those chemistry kits, and then you guys can actually see as we build the carbon chain, like the rotation of the bonds and how it, like I'll see that you guys see the 3D structure of it. And hopefully next term we'll see if we can have offline classes. How receptive or interested are you guys in having it offline? Wherever it may be, but like offline.
Depends
Yeah,
how.
offline is definitely
like-
better.
I mean, it's more cooler, I guess.
I'm
also
sorry, could you
easier to
repeat what you
understand.
asked?
No, face to face definitely has like its advantages. Definitely it's better. But in terms of your logistics and all the other things, with the pandemic, like distancing and all that, how comfortable are you guys?
For me, commute will be like very difficult.
Yeah, same.
Do you guys
You
like
have a masks on, right? So it's fine, I guess.
Have you guys got your shots, or are you still like not eligible or something?
We don't have any shots
Not
yet.
eligible.
no.
How old are
The
you?
We need
schedule's
to
gonna
get
come by
approved
January.
by the
We're all
government.
like 16, 17 years old.
Okay.
We are
So
technically,
maybe
so we don't.
soon, because I heard above 13, like people are getting.
Yeah, I think
And
they
they're yet
started
to
the
get
testing and
approved.
all. The
No, testing is also done. Only approve. I mean, the
only approval
government
is left, I
approval
think.
is left. Yeah.
So it should start by next year, Feb, I think. Jan or Feb. Late
I think
Jan, I think.
be offline only for sure, unless it's some new kind of thing. I don't think so, but yeah, I think 12th would fully be offline.
Okay.
But what did you ask? I don't know. I could not hear you.
Yeah, I was just checking how comfortable you guys would be offline from Jan onwards.
Malad would be hard.
So we'll see, like hopefully in a month, I personally want to get in minimum of, like if you have 4 Saturday, Sundays, then 2 of those I want to keep it in your school. Malad, obviously we'll have it a lot more frequently because you guys can come on weekdays also. Be pretty simple. Yeah. So I'll be looking at the schedule for January from this week, and I want to include offline classes. All right. Can we go
But
to the next?
till January, like for the month itself, could you also keep an option of online too? Like it should be optional.
Oh yeah, absolutely. It won't be exclusively offline. It will be both. That's what we'll be figuring out. Like, is it going to be 50-50 or weekly or twice, or like those finer details we need to figure, but definitely both. Cool. Is everyone done noting down both of these?
Yes.
Cool. So here, all you have to note or remember or focus on is what reagent we're using. Like, otherwise, rest of it is pretty simple, straightforward. यहाँ पे isomer हो रहा है, यहाँ पे aromatic compound आ रहा है. Just remember these things. The next one is also fairly very simple, straightforward reaction. So it is reaction with steam. Okay. So this is specifically focusing on methane. So when you take methane, make it react with steam in the presence of like nickel catalyst heat, you get carbon monoxide and hydrogen gas. It's fairly simple single reaction. This is important because this is the industrial preparation for hydrogen. So hydrogen gas has a lot of uses, like we've seen hydrogen fuels, rocket fuel, even otherwise preparation of ammonia, all these different, like even hydrogenization reaction, like we need hydrogen in the form of a gas, right? So obviously we don't find it in the atmosphere or on Earth. We need to make our own hydrogen, and this is how it is done. You take some natural gas like methane, make it react with steam, the presence of this catalyst, you get carbon monoxide plus hydrogen. That's basically the only significance of this reaction. Like that's what you need to understand. Yeah. And finally, pyrolysis. This is also more of an industrial commercial significance rather than like anything in terms of mechanism and stuff like that. So pyrolysis is mainly used in the petroleum industry. So it's basically cracking of petroleum. Pyrolysis is cracking. Have you guys heard of cracking before? Maybe 7th, 8th grade or something like that? What happens?
No, ma'am.
No.
Coal and
No, ma'am.
petroleum pay, you guys had a chapter, no? Way back.
In
I don't think
seventh,
they call it cracking. Like they show us the entire process.
Okay.
colon, but like if there's a different name for it, then I'm not sure.
Cracking only. Like if you guys learned about this, it'll be cracking. So basically, you take higher alkanes Then on heating it at like specific temperature, 773, like different temperatures, you get like different products. You end up like you basically break the chain, so you get the lower alkanes. Like depending on the number of carbon and hydrogen atoms, you either get lower alkanes and some alkenes and things like that. So basically, if you have like a really long chain, you're cracking this chain into smaller pieces. That's what it is. That's why it's called cracking. It's called
What is the
pyrolysis.
temperature?
Huh?
What is the temperature?
773 Kelvin. It depends. Like, let me check. Mainly 773 Kelvin. So yeah. It's called cracking because you're literally cracking the really long chain. Called pyrolysis because you're, again, lysis is breaking down. You're breaking down the chain using heat, like pyro, like explosion. Example, if I take C6H14 hexane, so on heating it to 773 Kelvin, I have three possibilities, again, depending on the pressure and like other conditions. I may get C6H12 plus H2. So basically I'm getting an alkene, or I may get C4H8 plus C2H6. So I got ethane and butene, alkene, this thing. Or I can get C3H6 plus C2H4 plus CH4. Basically, I get a mixture of lower alkenes and alkenes, and these are separated using fractional distillation. Like that's what happens in petroleum. You know, like rigs may you extract the like petroleum, all the natural gases and things like that from the earth, and then you process it like based on the requirement. Like the bigger compounds, you break it down to more useful smaller compounds.
Ma'am, what is the use of C2H6?
This is ethane. Ethylene is used in ripening of fruits and all that. No, ethylene is ethene. Ethane is used in preparation of, like, you have ethyl alcohol, acetic acid, ethanol. Like you start off with ethane and then you like all of these have, like, all of these are organic compounds, especially the smaller ones. They have like a lot of different applications. Or you may directly use it as a fuel, or you may use like elimination reaction, convert it into ethene or ethyne because they have their own uses. Yeah. The reason why we can't like predict the products, why there are so many different possibilities, is one, it's a free radical reaction, just like how you saw in halogenation. This is another case of free radical reaction. So it depends on, you know, which particular bond breaks and where this cracking is happening. If only the hydrogen splits up, you get this. If it breaks into two parts, you get this. Breaks into three parts, you get this. You can't predict it. One small correction, you guys. This is 773, not 777. And as I told you, this is used in like petroleum industries. So basically it's used in the preparation of oil, gas, like your diesel, gasoline, petrol. So you get all of these from kerosene. So kerosene ka actual like proper formula is, let me check.
Kerosene is also hydrocarbon.
Yeah. Kerosene, petrol, all of these are hydrocarbons.
These experiments, they don't have catalysts.
No, like you just literally you pass that gas through a heating thing, and then there's like different cubes for different, like at different, like you use basically fractional distillation to separate out these gases, but they're there in like one big tank. And let me show you guys what it looks like. So kerosene is it's a mixture of hydrocarbons. Wikipedia says it, the like you have the distribution of hydrocarbon length making up kerosene. It ranges from C6 to C20, predominantly in C9 to C16 range. Yeah, they're all hydrocarbons. If you guys are done noting this, I'll show you guys what the cracking that tank or that vessel looks like. So catalyst is not necessary, but sometimes catalyst is also used. Again, it depends on what your purpose is and what, how many products you get and like all that stuff. Okay. Kaveri, Sanath, and Rishad, once you guys are done. Kaveri, Sanath. Cool. So 4-7, right? Like we'll resume 4:15. What I'll do is I'll start off alkenes, and then I'll send you guys that MCQ for alkenes, or you guys can finish off that chapter practice. And yeah, this will finish the major part. Okay, but these are all flow charts, but this will give you an idea of what the rig looks like. So there's a huge.
I got disconnected for like 5 minutes. Did you start anything new?
No. I'm just showing you like how cracking takes place. Kind of like this, like you have a rig, gas, oil, and you make it pass through the furnace, you heat it up. So here cracking takes place. This is cracking furnace, and all the gases are sent through this tower. So this is where your fractional distillation kind of happens. So depending on the boiling point, different gases get out at different places. So generally to show it, like this is the whole, like if at all anyone takes a chemical engineering in future, you get to work with a lot of flow charts like these. This is the whole setup, including like the pumps and compressors and all of that stuff. But the rough, like if you want to know what is the crux of the process, what is the logic, this is kind of what happens. So you have the reaction takes place, you have like really hot gases. Then as the gases are heated up, think like cracking happens, you get the smaller ones. And then depending on, again, the boiling point, different gases get out at different places. Like you can see here. So petrol is right top up here. Then naphtha is over here. Then kerosene gets out here. Diesel oil gets out here. Fuel oil gets out here. So that way. This is how cracking, like that's the whole thing about cracking. So crude oil, you send in crude oil consisting of really large alkanes. They break apart and then you get the different components by fractional distillation. Cracking of petroleum, another term you might have used in the same context is fracking. I think that's what it is.
I think
Ma'am,
we'll
the
only
image
just like
you just
distillation.
Yeah, that's for extracting. Oh yeah. So
Ma'am, the image you just pressed, right? That one was there in a textbook.
this one.
If this is
Yeah,
called cracking, then we
the
have learned it.
distillation vat wala
Yeah.
like 8th.
Right. Achha, so they focused more on the fractional distillation part of it rather than
Yeah,
the cracking part. Okay. Yeah.
like at different temperatures, different components get, separated and all.
Yes. Correct. So that is
So basically in cracking too only something like this only happens, right?
So how do you get to these different components is by cracking. Like you crack the bigger ones into smaller components and each of these components gets out at different temperature. Yeah. All right. Let's pause here because yeah, that's the end of all of alkanes. I think I'm not sure. I'll have to see if you have specific alkanes. I think that part would be deleted. We'll meet back at 4:15 and we'll continue with alkenes.